Hello, welcome back to our Elastic community channel. This is Iulia from the DevRel team, and today we're going to be diving into more content from our Search Labs blogs. Everybody knows about LLMs, large language models. We've seen a lot of content come out about how they work, how to deploy them, how to install them, how to use various different models in combination with your current architecture, depending on different cloud provider, different model, different prompts and different tasks, and so on and so forth. However, I think it's ready to move on to the next stage, and that is, what do we do with these LLMs? In the next few videos, we're going to explore some cool use cases of using LLM outputs to enhance our search experience. Let's get started. In our first example, we're going to take a look at one of the most basic and important aspects of search, filters and facets. Now, you may not specifically know the terms, but whenever you search for something on a website or an e-commerce, you will see different categories that exist that all these products are stored under. And depending on which category you go into, different filters may appear. For example, if you look at technology, you will see televisions, computers, and gaming consoles. But if you look into the fashion category, you will have a different collection of filters such as dress, pants, skirts. So these filters are defined per different category, and they can be managed locally within your project. Now, at least that's how things used to be done. You would manually define these lists, have different hierarchies of which category fits with which filters, and deploy that to your platform. Furthermore, once you select the category and you start searching, you get even more options to further narrow down your search. And these are called facets. These will be relevant to the search that you're running. For example, if you're looking for a gaming console, you'll see the capacity, the storage, the video graphics card, and so on and so forth, so you can further narrow down and filter your results. So where do the LLMs come in? Well, if you have a very standard and classic catalog of products that never changes and never needs to be updated and never gets new releases and features never appear again, you probably don't need it. However, that's not really how it works in real life. So you may have experienced a use case that whenever a new characteristic or options or feature comes in, you need to re-index your entire data catalog just to be able to filter or use a facet with this new category. So having a manual hard-coded approach for all your filters and facets is a robust and stable approach, but it's not dynamic. So when new features come in, it's more difficult to change and adapt. And furthermore, even when you do want to reindex and change your data, you are still limited to the filters that you're coming up with, perhaps the characteristics that you get from the providers. But there are better ways to look at your data and better ways to understand how your users want to search for it. For example, when the first consoles came out, you probably were looking at color and material that it was made of. But eventually you started looking at the tactile feel of it, whether it vibrates or not, things that you couldn't have previously imagined would be developed. And nowadays, the way people search for these products become even more complex. Maybe you're looking for a particular vibe that fits a farming simulation type of game or a shooter type of game. And it's kind of hard to narrow down what that means or how that looks like in filters, at least for someone that's creating this data catalog. You're never going to be able to understand everything that your user wants and be able to programmatically put it in. But the LLMs are able to catch these trends much more easily. So what you can do is you can have this kind of LLM assistant go through the patterns that people search for, go through the text and the description and other semantic fields that your products have provided, and dynamically generate new types of filters that can be used per category. Now, of course, you would still have to have some oversight and double check that everything that was generated makes sense, but that would be a way easier task than doing everything by yourself from zero. So let's take a look at what that looks like. In classic Elasticsearch, it's very easy to introduce these characteristics and values that different products can have. So then when you're searching, you can use aggregations and term queries to find whatever kind of products you want and to create these filters. If we want to add this flow of using LLMs to dynamically generate new filters, this is also quite easy to do. Using the inference endpoint, we can deploy whatever model we want, and we can apply this model to our pipeline and re-index with new generated metadata. So in a few simple steps, you're able to ask the LLM with a prompt to look into the fields and create new filters and facets. You can make this limit to only, for example, 3 filters, asking for the most relevant ones, or you can use whatever approach best works for your architecture. And the best part is that this kind of dynamic approach doesn't stop here. You can adapt the model and the prompt depending on user behavior that you may be tracking on your website. If some filters are used more than others, you can choose to phase them out. If different features become more relevant, you can choose to include those into your prompt and still keep the human in the loop, but make it a lot more easy to follow the trends or to make your search as accessible as possible and as close to the experience that your users want. So there you have it. This is one example of using LLMs to improve your search capabilities by combining the new dynamic way of searching with the established filters and structure that your indexes already have. Hope you have fun with this experiment, and we'll see you in the next video for even more LLMs in real life examples.